Okay, so Chris, we looked at what this could do with 2 channels and an I2C bus.
Yep.
But what happens when we have more channels than that? And thankfully we have an MSO here, so.
Yeah, so let's take a look at the digital channels and some things we can do about that.
So we've got this cable here. This is a nice complex one. What does this let us do?
Yeah, so this is our sort of breakout for the digital channels. So we've got a couple pieces here that can go into headers on boards.
Okay.
This set also comes with some flying wires and clips, so you can get to a number of different ways to connect to it.
For any of your test points that might be on the board when you don't have a nice convenient header.
Yeah. So what we're going to do though right now is we're going to take this, plug this guy into the front here, and then we're going to take our first 8 channels here, our D0 through D7, and put it over on this header here.
And what are we going to be looking at here on this test board?
So right now, what we've got up on the screen already is the output of an 8-bit DAC. And that DAC is then, obviously, we're kind of creating a sine wave with it.
Okay.
And now, what we want to do is look at how that's being created. So we're going to look at the parallel bus that's kind of driving that.
Okay.
Yeah, so let's turn on that. So the first thing we want to do then is hit our logic analyzer button here, our LA button. Turn that on. And we can see that up on the top of the screen. And then I find it a little easier if we go into the trigger menu. Because the scope is really all digital, we can trigger on any of these channels. We can analyze any of these channels. So just like we did some analysis before with the 2 main channels, you can do the same things with any of the digital channels.
And this lets us handle up to what, 16 channels?
So you can do on this scope, you can do 16 digital channels and the 2 analog channels all together.
Oh, awesome.
Yeah. So here we've got, we look closely, we've got this running, and we've got at the top of the screen, we've got 5 of the bits from this A to D, and you can see how they change as this signal is being run in the background.
So then the digital to analog converter is interpreting the 5 signals we see here and producing an approximated sine wave out of that?
Yep.
Okay.
That's what's happening. So, that's another way. So regardless of what what you're working on, if you have some kind of a micro on there, you've got some kind of a either parallel or serial bus that's somehow getting you to the real world, right? Whether it's a sensor on your IoT device or some kind of output actuator motor, whatever it is, you've got some kind of a signal. Maybe it's a PWM signal, maybe it's a straight 8-bit parallel bus, but you want to coordinate that data. You want to see what the bugs are. So you want to check both the real world analog stuff and the digital stuff, correlated in time. To do your debugging and analysis.
Well, because you could, I guess, run this in reverse, actually, seeing what an ADC is giving you, an analog to digital converter.
Absolutely. So,
okay.
Yeah, that's kind of the neat thing about a real nice modern MSO is you get to see both the digital and the analog together, and it's great for that sort of embedded design work.
And do you have the same decode functionality when you're dealing with 8 or 16 channels?
Yeah, absolutely. So you can do, like we did before with the I2C. You could do parallel bus, so you can look at all of them together and coordinate them as hex or binary data as well. And you can do your I2Cs, your SPIs on the digital channels or the analog.
Cool. Thank you very much.
Thank you.